Hello? Okay, there we go. So I'm going to talk to you guys about make and stupid shell tricks or Seth's favorite Unix utilities, all that kind of stuff. Everything in here is actually a valid command if you've got the files in there. So you can play around with it. The slides are online. This is going to be a little interesting. I have a 10-minute slot and I have 109 slides. So we're already behind schedule. So 2EFFVJT, and then you can go through the slides at your own leisure. I'm going to skip really quickly through some things. Why do we want to use make and stupid shell tricks? So that we can do reproducible data flows that are repeatable, that are self-documenting, and that represent transformations to data as transformations rather than just changing. As Hillary Mason from Bitly, now from somewhere else, says click, 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 click doesn't scale. That's a great way to figure stuff out. But when you get past that, you want to script things so that you can swap in new data, get a new extract, etc. So I'm going to jump straight in. If you're on Windows 10, no worries. There's this thing called bash on Ubuntu on Windows on your computer on Mars. And you can use that and you get all of these stupid bash tricks available to you. So we're going to start with some shell fundamentals. A pound sign is a comment. $, is a prompt. So if you see the $, it's the thing that sits at the beginning. Type everything after that. -- help is really useful. That'll give you short options for things. Man, which is short for manual, will give you the man page for different commands, and that's where stuff gets explained. You get all sorts of different options, more detailed. So if you want to do this and then you want to do that, you throw a semicolon between them. If you want to do this and then you want to do that, but only if this succeeded, put a double ampersand. If you want to do that, unless this, so if this fails, you want to do that, you use a double or, a double pipe. So it's this or that. So standard file descriptors are really useful. This is also known as standard I/O. Standard in is where you get text in from a keyboard from another thing. So what I did here is I'm writing out to a file called greeting. I'm putting in hi, and then I'm sending Control-D, which is an end of file character. And then it landed in the file. So that's something from standard in. And I'm redirecting it to greeting, so that's using standard out. Standard error is also really useful if you want to spit out error messages. If you send it to file descriptor 2, it means that if you are piping that to a log somewhere else, it will not show up in your log. So if you're looking at, if you're taking standard out as your standard in, you will get things. Sorry, this is a little in the weeds, but that was the intent. If you want to send somewhere nowhere at all, dev null is your friend. You can send files, you can send output to another file. You can append using a double greater than. You can send standard error to standard out, so they show up in the same place. You can pipe things together. This is one of the most fundamental things. So you throw a pipe character in, and you can say, okay, show me everything in password that includes the string calendar insensitively. That's what grep is. We'll get there in a second. Exit codes are also really fundamental. When a command ends, it's going to end with an exit code. If you've got an exit code of 0, that means it was successful. If something failed, it's going to be not 0. So it could be 1, it could be -1, it could be -53. It doesn't really matter. It's just not 0. That's really useful if you want to fall back. So if something doesn't exist, you want to do something else, check your failure codes. Make is a really useful tool to do reproducible workflows using the same input, generating the same output. So you can keep running the same thing over and over, and you'll get the same output. So if you run make idempotency, it will do one thing. If you do it again, it will do it again. If the file exists, it'll skip it, which is really convenient. We have targets, which are the thing before the colon. That's the thing that you're making. So you'd say make this, and then what it would do is it would create a file called this. We also have prerequisites, so one thing can depend on another. So if I want to make this, it first needs to make sure that that has been made. So in this case, that is a file. That could also be another target. You can do some other things. J2 lets you run it in parallel. J, however many instances you want. So if you write your Makefiles smoothly. You can run them with as many CPUs as you've got, and things get done quicker. We've got some variables. $@ is the name of the target. $caret is all of the prerequisites, so that and the other. The first prerequisite is often what you want, so it looks kind of like a scissors. So it's $ less than. If you want to extract things out of your prerequisites or really any other variable, you can use word, and there are a whole bunch of other functions in there that I'm not going to get into. Looking through my Makefiles, word is the only one I use. Catch-all, so a %. If you want to have a target that catches anything, throw a % in. So I could make this, make that, make the other, and each of those would end up with the content 42 in them. This is where I'm going to start going really quickly. These are a lot of really useful commands. Yeah, I wasn't going quick enough, sorry. So tools to explore. Who am I? PWD, date, ls to list things, cat to look at stuff, less to page through things, head to look at the top, tail to look at the bottom, env to see what's in your environment, find to find things, md find to really find things, man to figure out what they do. And then you can change stuff. You can create files with touch. You can copy them, you can move them, you can delete them with remove. You can create directories with makedir. You can remove directories with rmdir. You can delete stuff with rm-r. Careful, there's an f argument as well, but that won't prompt. You can search for things with grep. You can search for things that aren't there with grep-v. You can count stuff with word count. If you do wc-l, you can find out how many lines there are in something. You can extract fields from JSON and pretty print it with JQ. So in this case, I'm pulling the name property out of a file. You can replace stuff in a file using sed with a substitution, so substituting this and that. You can extract columns from a CSV using cut, where you can pick a delimiter, which is our comma in this case, and we want the first and third fields. We can compress things, unzip. We can list what's in a zip file. We can create zip files. We can open tarballs. List tarballs, create tarballs, compress more things, uncompress things. We can always return true. This is convenient. We can always return false, also useful. We can download stuff from the command line. The -f is important because without the -f, you will get an exit code of 0 always, meaning that if something didn't work, it will claim that it did. You can also use wget. You can open stuff, and that'll open it in whatever your system wants to use for it. You can display progress with pipe view, PV, so you can see how fast things are going through. You can write to standard out, and you can write to a file at the same time using T. Okay, so we're moving on into bash stuff. This is what's called a hashbang. It's the first line in a bash script, and it says, this is the command to use to execute this script. And so if it's a Ruby script, it might be user bin env Ruby. 2 minutes, wow. Okay, some useful options for scripts. Variables, you can assign them, you can get them from commands, you can echo them. You can provide default values, you can replace stuff, you can replace everything, you can get substrings. You can remove suffixes like file extensions, also really convenient. You can do math. You can do control flow with if, else. You can do while loops. You can loop over things, so looping over content in a directory listing. Man, test. I don't actually know what that means. Anyway, you can find out what the file name is from a full path. You can find out what the directory that a file is in. And here's a couple of recipes that are a little bit more useful that break things down a little bit. What this is going to do is it's going to take a source shapefile, create a source JSON file using ogre to ogre. It's going to convert it to WebMercator. Shout out to all the web people in the audience. It's going to create a GeoJSON file, and it's going to it's going to create source.json, $@, and it's going to use source.shape as the input. You can reproject stuff in the same way. A little bit more complicated here. What we're doing is we're silently creating a directory that is the directory of the target. So in this case, it's creating data. And then it's downloading from the Forest Service a zip file and saving it out. You can also do this with database tables. So If you've got Postgres, you can say, hey, does the table wilderness exist? That's what the subst is doing. It's stripping off the DB. And then it's checking, and if it doesn't exist, what it's going to do is it's going to run psql, and it's going to load wilderness.sql. Some resources. These are things that I've found useful. I'm putting a warning on the Toner-Cardo one. It's an example of what can happen when you don't know where to stop. You want to take things and make them smaller rather than going crazy complicated, which is why you want to stay in fundamentals. And we are out of time, but that's the end. So, thanks.
We do have time for a couple of questions, if anyone has any. All right.
Okay, maybe you're doing this already. I was just going to ask if you can go back to the bit.ly link so that I can download it and read it.
Anyone else?
Hi. So why would you use, in your opinion, a Makefile versus a bash script versus a Python script or Node script or something?
I would actually use all of the above. I'd have the bash script, the Python script, create the files, but then I would wire it up with make so that if the file already exists, make won't recreate it. So the advantage of using make is that it will conditionally create things according to the presence of prerequisites. So then if the source file doesn't exist, use Python to create it. If it does exist, make will just shortcut that. Anything else? Cool. Thanks very much.